Hello everyone, this is Saeed Mohammed. I'm with my partner Idris Elmi, and this is our batch processing and workflow automation final project for advanced GIS programming with Python. To begin off, we have our import statements, which basically import everything that we need. It imports ArcPy, imports request and zip file as well. Then moving on to this section right here, this is basically like this is the user inputs. So it asks the user for inputs. The script takes user inputs from ArcGIS Pro. So this includes the year, the climate parameter, and the output folder. Then it uses those inputs to build the correct Prism download URL, which also creates the output folder. Then moving down to this section right here, this basically extracts the data from the Prism data. It extracts the 12 months, and it basically for each month it builds the file name, downloads the zip file from the Prism website, saves it locally, and then extracts the contents from it. So instead of having to download each data manually, month by month, the script automatically does it for you. Then moving on to this section, this basically creates the database, the geodatabase, to store the processed outputs in it. Then it searches through the output folders to find all the TIFF rasters that match the selected climate variable. Then moving down, so this function right here is basically a helper function. It extracts the year and the month from each raster file name so that it makes it easier to label the outputs correctly, and also group the rasters into quarters, which will later on be very helpful in this project. Then moving down to the raster, this section right here basically is the projected raster section, which for each monthly raster, we reproject the raster into the UTM zone 13N so that all the outputs are in the consistent coordinate system. Then moving down, this is the clipping raster section where we clip the rasters and we save them locally by extracting the mask first and foremost, then we saved it. Then the zonal statistic area, basically we basically calculated zonal statistics for each Kell County in Colorado, basically. Then in this section, this basically creates the annual raster data set. So it does it for if you're trying to look for the mean temperature, if you want the maximum temperature, minimum temperature, it's whatever the user does. But it uses self statistics for each to basically clip the raster for the annual function, and then it saves it over here. Then we move down to the quarter. This basically breaks down the months into each quarter. So quarter 1 would have months from 1, 2, and 3, quarter 2, and so on and so forth. Then we create a raster, dictionary, and we basically do the same as we did for the annual, but this time we break it down into quarters for this section over here. Then we move down into the section where we see the difference between summer and winter. Well, basically we see the difference between two different quarters. We just chose summer and winter. You're able to choose fall, spring, whichever one. But we felt like summer and winter would give us the biggest difference. So it's pretty clear for the user to see. Then at the end over here, this is just like the report for the summary basically returns. It gets you the raster properties for mean, max, and minimum. And this is the way it runs it afterwards so that it's visually clear to the user on what is printed out. Now I'll move to the ArcGIS project so you're able to see it happen clearly. So here in the GIS project, if you look to your right hand side, the script basically asks for a year. We can use 2005 as an example just to make it easier. For the climate, we'll use the mean, temperature mean. And for the download folder, we'll use the Prism data because that's where the folders are in. And for the clip, the boundary would be the Colorado County. And the output folder, we would then move it to our final output folder. And once we run it, it takes a little while for everything to run because it's pretty big, but like the messages it shows us is like it's downloading, like it finished downloading some of the zip files. But then again, like we said, it's a lot of data for it to finish downloading and recuperate, so it might take a little bit of time. So I'll show you the end result. So this is the end result right here. As you clearly see, the year we picked 2005. We picked the mean temperature. Basically, it produced the monthly rasters that was produced for us, all 12 of them, including the annual one, and also it produced the 4 different raster quarters that we gave it. Plus, when we compared summer and winter to get the highest difference, it also produced that too. As for the annual raster statistics, it basically, what it did is it gave you the annual mean temperature of around almost 8.5, and then the minimum temperature, was around like -14. Same thing with the maximum temperature. And then for the quarterly climate outputs, the script groups the monthly rasters into 4 seasonal quarters and calculates an average raster for each quarter. These outputs help visualize seasonal climate patterns across the study area. And then when you look at the monthly zonal statistics table, it just basically generates zonal statistics tables for each monthly raster. These tables summarize climate values with each county boundary. This allows users to analyze how climate conditions vary between counties and compare regional climate patterns. So after the tool finishes running, it generates a summary report that lists all the data sets processed during the workflow. This allows this report basically helps verify that the analysis completed successfully and provides a quick overview of the results. And thank you so much for looking over our project.